Let's take a look at how we can use our power of a quotient property. This first part here says 1/4, or 1 divided by 4, raised to the third power. Okay, so 1 divided by 4 raised to the third power. Remember, that's like saying 1 to the third over 4 to the third. Now if we go 1 to the third, well, 1 times 1 times 1 is 1. 4 to the third, 4 times 4 times 4. Well, 4 times 4 is 16, times 4 ends up being 64. Okay, so again, that's a pretty small number. We should go ahead and write it as 64. Let's look at this one here. We have a negative 4 over x squared. What this means is a negative 4 squared over x squared, which is a negative 4 times 4, which is 16 over x squared. Don't forget about that negative sign. It doesn't really play into anything here because it's not a negative exponent or anything, but we have to remember that's like saying there's a negative 1 there, and so we multiply our problem by a negative 1. Now if you look at this example, it says 3 over 2 raised to the negative 4th. Remember, if it's a negative exponent, we take the reciprocal. So I'm going to write it as 2/3 raised to the positive 4th. When it's a negative exponent, we take the reciprocal, and that gets rid of the negative. But we're not done there. I now can say that this is 2 to the 4th over 3 to the 4th. And if you go 2 times 2 times 2 times 2, you get 16. And 3 times 3 times 3 times 3 ends up being 81. Again, you could multiply 3 times 3 times 3 times 3, or just put 3 to the 4th in your calculator, and you get 16 over 81. Okay? So again, this property just wants to make sure that you're applying the exponent to both the numerator and the denominator. A couple more examples. Don't be intimidated when you see a crazy looking expression like this. Try to break it down so all similar pieces are together. Here's what I mean. The first thing is we have to recognize that these are all multiplication. This is 3 times x to the third times y times, if I multiply across my numerator, 12 times x squared times y squared. And the reason I like multiplying it out like that, because a lot of times we like to give this 3, well, to the 3 here, to the whole number, and that's not true. The 3 belongs with the x, not with the 3. If I did the same thing on the bottom, I'd have 4 times x, and I'm going to write it to the first, I'll put it 1 here with the y, times y to the third. Now try to simplify the top and the bottom. If I look here, I can multiply a 3 and 12. If I multiply a 3 times a 12, I get 36. Now notice here, I have x to the third and x to the second. Two bases, same base, being multiplied. That's like saying x to the 5th. You add their exponents. If you have 3 x's and 2 x's, that's 5 x's. Then we have y to the first and y to the second. Again, same principle. We can write that as y to the third. Now do the same thing on the bottom. There's nothing to multiply 4 by, so I'll leave it as 4. Nothing to multiply x by, so I'm going to write x to the first. And nothing to multiply y by, so I'll write y to the third. Don't stop there. Once I do that, I've kind of simplified the top and the bottom. I'm going to take it another step further, and I'm going to break it up so each part goes together. I'm going to break up 36 over 4 times x to the 5th over x to the first times y to the third over y to the third. When this happens, if you go 36 divided by 4, you get 9 times x to the 5th over x to the first. Now look at here, same base being divided. We subtract their exponents. So this becomes x to the 4th. Now here we go, same base, both are y's, being divided. So we subtract the exponents and we get y to the 0. So this ends up being 9x to the 4th, and since y to the 0 is 1, multiplying 1 by 1 isn't going to change the problem. Notice how much simpler that looks than that expression up there. One more example. This is saying 3x squared over y raised to the third. Now, what that means is we have 3x squared raised to the third over y to the third. Remember, this 3 on the outside parentheses goes to everything inside. Right here, this is not 3 squared. This is just 3 to the first power. So we can write that as 3 to the first being raised to the third. Remember, one base multiply the exponents, so 3 to the third, times x squared and raised to the third. 1 base, power raised to a power, that becomes x to the 6. We multiply the exponents, all over y to the third. Now in this case, there really isn't too much more to do. 3 times 3 is 9, times 3 is 27. And there really is no way to simplify these since they're different bases. So we can write as 27x to the 6th over y to the third. The way I showed you guys here on these examples, there are more than one way to get to these answers, depending on what property you apply first. My advice is just to keep trying the properties, okay, and keep going until you can't do anything else, and you should come up with the correct solution.